Sailing goes back as long as I can remember. I was maybe 7 or 8, and we were studying for the White Sail Level 2 exam. Part of that was understanding how a sailboat works. And that's actually kind of a complicated thing to try to understand, especially when you're 7. And then I wanted to understand, well, how do you make the sailboat go faster? And that's a great problem in aerodynamics. I really do think a lot of my interest in physics and consequently fluid mechanics has come from trying to become a better sailor. I study physical oceanography. I try to understand how the oceans work, in particular in things called western boundary current jets, things like the Gulf Stream in the Atlantic and the Kuroshio in the Pacific. And these are some of the most energetic currents in the world oceans, and they're the ocean's primary way of transporting heat. So it's important to understand what controls their strength and their transport. I've been involved in this large-scale observational program called KESS, and we put out a suite of many different types of sort of state-of-the-art instruments out in the Kuroshio extension, which is about 500 miles offshore the coast of Japan, and they make measurements for a duration of 2 years. My motivation is equally curiosity-driven, and then also sort of bigger picture to predict and adapt and perhaps mitigate future climate changes.
Stephanie has been working, I would say, in a kind of very creative way, both theoretically and using observations from going to sea. That's really remarkable. I think it requires a mind like Stephanie's.
I set the speed to 0.5 F.
Very, very bright.
A measure of the rotation rate of the Earth.
Very creative, very organized.
Start it up.
It's going to be one of the really good theses to come out of the department.
I kind of see this as a game in that we go out and we observe the world, and it's incredibly complex and interrelated. But what's satisfying is to take a much simpler system, so like a numerical model or a laboratory experiment. And the satisfaction comes when you get convinced by looking at the observations that your simplified system that you do understand has some relevance to the real ocean system.
Stephanie's been great as a student. The other physical oceanography faculty, I think I'm lucky to have her. She's been moving right along in her thesis towards completing it. At the same time, she's been out running triathlons or sprint triathlons or bike races and all sorts of races.
I think you should have as many adventures as you can in your life. I think that would be a good goal. I think it makes you feel alive. My friend and I rode a tandem bicycle across Canada. So our goal was to do it in 6 weeks, and we did it in 6 weeks, 2 hours. We averaged about just over 100 miles a day. You remember kind of the challenging times most strongly, the headwinds in the prairies and the rain in northern Ontario. It's probably the longest period of time where I've been outside so much and looking at the sky and looking at the clouds and watching the wind. We were obsessed with wind direction because it really makes or breaks your day in terms of how easy it was to move forward. When I watch the wind blow over the water, or if I watch the wind blow over a field, and I see the small-scale structure in that wind field, I can't help but think about the fluid dynamics of that. I think it's really interesting and fascinating. I've gotten involved in some programs that sort of introduce kids to science, and often those are introducing young girls to science and providing sort of mentors for them. My office mate has a 5-year-old daughter named
Yuval Caspi.
We do science projects together.
She comes and picks me up from school.
So she comes over to my house for the afternoon, and we investigate things like how color works.
We put green and red food coloring.
Or how different parts of the body work.
How the heart pumps blood.
How chemistry works.
We make a big mess.
And have a lot of fun, but also kind of explore questions and figure out things by means of experimentation.
I really like playing with Stephanie, and I like doing science with her.
And it's not just wanting to be good, but she wants to communicate. She wants to share her ideas, and she wants people to understand. I'm eager to see all the wonderful things that she's going to do, because I have confidence she's going to be a star.